42, trapping rainwater. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it is able to trap after raining. Okay. And this is the, and I mean, I don't know how to describe this map, but this, you're listening but not watching, then there's just a picture of water that's trapped by pixels. Okay. So this is on each, so the array, so the implicit xy, if you will, is on the thing. Okay, so this is like a height map or elevation. I guess they actually call it an elevation map, so I don't have to lose it. Okay, cool. Hmm. Let me think about this. I think so. In these kind of problems, uh, I think I generally think of them as kind of event type problems or excuse me. Uh, what I call sweep line problems or line sweep problems. Basically, you're doing a, and maybe this one is more straightforward, kind of. I don't know. I have to kind of. I think. Well, let me finish what I was saying, which is a line scan algorithm where you scan from left to right. I don't know if this stream is mirrored, but oh, I'm not even showing anyway. But you're sweeping things from left to right or right to left, depending on how you want to do it. And then on each event or each action, you do certain things, right? Um, but okay, and I think my first intuition for this problem is try to figure out, well, what does it mean for water to be trapped, right? Um, hmm. And I think hmm, my I'm just so my intuition isn't always right, but so that's my disclaimer. But I'm that said, I'm just gonna talk about what I'm thinking about in different ways. And I think right now my intuition is that maybe there's something that I could do with a stack where you pop things on and off. Maybe like you have to one, and then you go to two, and then you try to figure out what probably traps water, right? Um, and for me, and this is not something that I know for sure. It's just me kind of an observation, I guess. So you know, uh, for me, looking at the array and the kind of the picture here. Oh, thanks, Marcos. But the I think what I want is the next number that is like, I mean, the intuition or the English version is that, like, you kind of get a dip, right? But what is a dip? Well, you want the next number that is uh, equal or higher in a way. But eh, hmm, is that good enough? Because for two, well, two is the high point, and then you go to three. I think so. That part is maybe straightforward-ish for some definition of straightforward-ish. Yeah, I I don't know how to say it. Y of PSA. But yeah, I'm also struggling a little bit. But so I think like the going up part, I guess I could reason something. But and my question is, can you always decompose? Yeah. Oh, hey Johnny. Yeah, I definitely feel like people always talk about this problem, but to be honest, well, I've probably done it like decades ago, but I haven't done it recently, so I always remember. But yeah, I'm still going to go through my thoughts just to because I think so, it's one thing to know something, but it's one, well, you have an intuition about something which may or may not be true. Maybe it's because of experience or whatever. But I also want to make sure I got it. But so I think you could decompose this problem as a weird, like a longest. Yeah, does it? Okay, but yeah, sorry. I think you could maybe decompose this problem as kind of like almost like a mountain where like it goes up and then it goes down kind of way because because if that's not true, like because if you have like if you think about like is there it's there. I wish I could. Like I'm just looking for like maybe some way to draw it to visualize what I'm thinking. But basically, if you have like a twin twin peak type situation, then actually you could kind of merge them into one peak where like you have water in the middle, right? So in that case, it's always just one mountain where you have almost like an increasing slope, and then kind of calculate the water that's in the climbing upside, and then also the decreasing slope, which is you just get the water that's trapped on the other side. And to kind of simplify that, even you just get the highest point, and then you could kind of do the same algorithm going up, but on both sides, right? So you can kind of do that. So I think that's kind of my intuition for this problem. Uh, and then and then that problem. So now we kind of decompose this problem into a I don't know if it's an easier problem, but it's a different problem that we can kind of go around. And then now the question is, given an increasing elevation map, calculate how much water it is trapping. And for that, given one point, and I'm pointing at the first box on the left, which corresponds to this point, at I don't know 0, 1, 1 or something. I don't know because the box are not on the thing. But then what to calculate the next to calculate the area, you just calculate that from that point to the next value that is higher or well equal or higher, right? So in this case, you look for the next number that is higher or equal to a greater or equal to yeah, I don't know why I said it so really, which is 2, and then you do the next one, which is 3, and then that's your increasing side, right? Because the other side you just do the same thing but backwards, and then you get the 2 and 2, and then from that you could just run an algorithm that uh, yeah, and I think from what we said before, so actually what I just said probably isn't that. I mean, it's true, but that's not how we calculate the water drop area. So how you would calculate the water drop area is that you have a stack where, okay, this is 1, so now you push in the 0. And I mean, maybe it's still true. No, no, yeah, you push stuff on a stack, and then you could pop them off once you find the next greater or equal to number. And then you just do math based on the endpoints, which is the min of, which is probably the starting point, but the min of the two kind of mini peaks, if you will, and then you just kind of do the math that way. Uh, okay, I think I have what I need to start coding, um, and that's I think it's am I in, I think this is O of n because everything I said is just linear. Because stack popping, pushing, that means you only look at each point once or twice or something like that. Well, maybe, I don't know, maybe 3 times. But either way, so n. And to get the peak, you have a linear scan, so that's probably fine too. Um, and if you have multiple peaks that are tie breaking, you could just choose one. I think it doesn't really matter because then you get it. I mean, just dividing the problem and then mirror it, right? Which you don't even have to. You don't want to, I guess, but it makes it slightly easier for me. Uh, Okay, I think I have what I need to kind of start coding. But definitely, if you all have questions while I'm rambling on, let me know. Um, how long did I take? Okay, 10 minutes of rambling, not so bad. uh, maybe that's it. Okay, cool. Uh, hmm. Okay. Let's say peak is equal to. Okay. Well. Again, I'm just gonna check for 0 because I feel like once in a while I get caught off guard because they don't tell you what the end limitation is. But if it's linear, it's probably as fast as you're gonna get. So I don't worry about time complexity. Like when I'm doing n squared, then I would be like, what is n? And also it sucks that they don't tell you what n is. But that's also kind of, I don't know. I mean, it is what it is. Um, but yeah. Um, Yeah. Awesome. Oh, whoops. Yeah, actually, I don't even. Should be heights, I guess, but oh well. Actually, I want the index. Yeah, okay. Is that a? Okay, I guess it's a function, not a code. Should be heights. That's why. Otherwise, I would name this variable height. It's kind of weird. Maybe I could rename it. I don't know how Leetcode does it if I change the input. So okay, I'll just leave it like this for now. But just for code readability's sake, I guess. Okay, let's go pick index. Okay, so now we have, okay, solve the problem from 0 to peak index. And then, is there an easy way to get a reverse iterator in Python? I always forget it. Yeah, okay. But let's just solve, I don't know, increasing maybe? Let's just do height. What am I doing? Oh, yeah. Height from 0 to thinking that maybe off by one. I'll double check that. I'm always sometimes off by one of these things. I guess I'll just put out heights and then double check. Oh man, did I change something? Oops. Oopsie, easy. Okay, so this, so I would like the one, I would like the 3 to be in there. Okay. What did we say we were gonna do? Okay. Um, oh, yep. You're not wrong, Johnny man. No, you're right. I fixed it. I don't know if maybe your feed is a little lag though, but thanks. What am I doing? Okay. I guess this one I could call height. What am I doing? Okay, so get numbers. Does that work? Is it? Oh, it's just a pen. Okay, still a pen. I guess we put it on the bar. Is there a stack in Python? Or I'm just doing it in a list in a weird way. Okay. Well. Oops. Sorry, I'm used to do a lot of Python actually, but I still struggle a little bit with now. I don't remember what things are. Okay. So yeah, so that's right. Because it's okay. So that's it's what I expect these things to do. I like to test my assumptions early so that I don't know. I mean, I could have also Googled it, but I feel like this is slightly quicker. Um, okay. So once again, um, so how do we want to do this? We said a lot of English stuff, but how do we translate that into computer stuff? Okay. Okay. So heights equals heights. If the stack is empty, we just push the stack. Oops, that's not if it's empty. If is there a peak? I guess it's just stack with -1. What else? I guess I'll just do continuous. I don't have to do what else. Now, okay. We get the height, and now if the current height is bigger than the peak, and sorry, PEAK peak, the stack peak top, something like that. But we're talking about peaks, so it's been very confusing. But if it's bigger than that, then we just pop the previous one. No, then okay, then we just try to solve it. I guess there are two ways to do it. I'm trying to think about which way I prefer. Because there's one where you do the math with kind of throwing it from the bottom up, and then another way maybe you could throw it from the left to the right or something like that. Essentially, is what I'm thinking about. Okay. And I guess for this case, it doesn't matter per se. If that's why it's a little weird, but. Okay, maybe I tried too much to rely only on stack. Maybe I just do what I said I would. Okay. Peak is equal to the second one. Okay. Well, maybe 0. I don't know. If height is bigger than peak, then you do your math, which means we go through the stack. Okay. I guess I have to. Was it area? Oh, water? Okay. Stack that up. Water. True. Minus peak. Because peak is the min between height and peak. Okay, something like that. And then, okay. And then now peak is, peak is equal to height. Okay, is that good enough? No, you have to add something. Else, stacked up. I guess it doesn't actually even have to be a stack, but because you just keep track of the list of numbers. But is that right? Well, I guess -5 is usually never right, but I also have 2 directions wrong. But it's actually kind of right because we only do it for half of it, so it's kind of actually what we expect. Whether it's right, at least this is what we expect for the input, but whether it's correct totally is another story. Okay, and then now let's just say we add that to this. But then reverse. Something like that. Is there a reverse? Let's forget it. Oh, well. Alright, I'm just Googling. Hang on. Reverse this. I thought there's a reverse from Yeah, it's dot reverse, but I knew the dot reverse one, but it does it in place, right? What do we want is to reversed with the D. Reversed. Yep. Okay. Well, uh, hmm. Well, let me make sure my inputs are right first. Well, thanks. I could just string this, right? Is it? Oh, I guess string is just what we just saw, so that's not helpful idea. I think we have to clear the stack maybe at the end. I don't know, not sure. Uh, okay, so 1, 2, 1, 2. That is what we want. So that's right. Then why is that wrong? Oh man, I printed too much stuff. I have no idea what I'm printing. And now I've been running it too often. I'm DOSing the system. Oh, this should be okay. Still shouldn't matter, maybe. Why is that the case when you get to 3? Because the 3 should do stuff. Why is that wrong? I mean, I know that this should fix. So I know that this should fix it for the answer, but I want to also double check to see why that's wrong. Because I don't include 3 in this, that's why. Okay. So this is maybe. Hmm? I have to go back and fix it, but now I think we have an edge case fixed. Okay. So yeah, so this should be good. I mean, this should be more right. Because I think before, and I half noticed it when I printed out, but I think I just didn't take it to mind because it was only showing 1, 2, 1, 2, but it should be 1, 2, 1, 1, 2, 1, 2, 3, something like that. Yeah. Let's test some empty cases and stuff like that. But I don't know. Let's just see if this works. And let's see. YOLO. Okay, cool. Yay, it's fast, but it uses a lot of memory. Why do I? Oh, I was like, I guess, well, yeah, I don't, I'm not gonna worry about that. Oh, well, and also because I probably reallocate memory for this reversed. But it's a reversed iterator, so it doesn't actually allocate memory, right? Huh. I don't know, but I don't know what people are doing with less memory usage, but I don't care that much. It's for the context of this. But cool. Yeah, I would say so. Full disclosure is that as Johnny One Man kind of mentioned, this is still a very standard interview problem. I think so. I've not asked this at all. Well, I've never asked this personally, and I've never tried to solve this per se. And so I have some vague ideas, but I've never looked into this problem, or at least not in the last 10 years, because I might have tried it like I don't know 15 years ago. Then I don't know. I don't remember that long ago. I solved a lot of problems, kind of. But all that said, my point is that even though I personally have not asked this question, I definitely have been what do they call debriefs where other people like my teammates or not necessarily my teammates, I guess, but people who are on the same interview loop or like they, you know, on an on-site of 5, 6 people interviewing one person, and I've definitely heard this problem asked before. So it's a very standard problem. It's a real thing, and if I were interviewing, I would definitely like if I was trying to get into a company, I would definitely practice this. I just and it's a good thing that you brought it up because I guess now I practice. But so it's definitely very standardy. So I definitely think people should know this, and I'm glad that I kind of got to work on this without knowing, how to solve it. So that I could give you a more kind of genuine thing. And so my assumptions were all kind of correct, which I'm very happy about. But but yeah. So this is I mean, whether I think this is hard or not, I think maybe I don't know. Like it doesn't matter in the sense that like I've definitely have seen this problem before, or I've heard directly that other people I know asked this problem before, and it's something that will show up on interviews. I mean, maybe you don't get it because sometimes you're lucky or unlucky, depending on how you want to frame it. But this is the difficulty that people expect. And in terms of postmortem of my code, and uh, everything is O of n, as I said. I mean, we keep the stack, but other than it, we're just O of n in both time and space. But generally, that's the only thing. I mean, yeah, and there should be an iterator, so I don't think that like is extra space. But even if it did, it's O of n extra space, and everything is O of n. So yeah, as an interviewer, I don't. I mean, I don't know if I have any preference about this problem. I generally don't like asking this problem because I feel like enough people ask this problem that there's a collusion more often. Maybe not. I don't know. But that's my logic for never asking this problem. But I have kind of heard about it. I just never kind of actually dig into it. And that said, there are many variations of this, so I don't know that it's fair that but they're all kind of similar. So that's something I would think about. And I think in terms of learning, I think that's which is more important than memorizing the answer is think about. I think how I would think about it is kind of what I kind of said in the beginning, which is think about like a sweeping algorithm. What happens, and like kind of like almost like a streaming algorithm where okay, you get a new data point. What does that mean, right? And I think what I did, which I like, maybe I don't know if that's a brag or whatever, but something that I like, because I don't always do this. Sometimes like I solve things not in a nice, clean way, but this time I did because I don't know. Sometimes you are on those roads or you think about things the right way, but sometimes you're not. So that's why I'm a little proud. But anyway, is that I am able to divide this problem from two problems into two subproblems into break one big problem into two subproblems so that I don't have to like you. And I've done this in the past in a bad way. If you go through my stream, which is that I would maybe copy and paste this for kind of the decreasing order and maybe do some extra math and if checks and stuff like that, right? And yeah, you could get it to work, and people do, but that's clearly less ideal than what I did here with kind of breaking this into halves and then kind of solve it that way. So I think I'm very proud of that. It's not meant to be a flag. It's just that, like, even I don't get it all the time. So that's why I'm just want to point that out. In terms of cleaning the code, maybe there could be minor cleaning, but I feel like this is mostly okay. My variables are mostly named right, so I don't have to go back and change it. I think sometimes I would, even if I don't do it, like physically do it, I would tell the interviewer like, oh yeah, this variable's name is kind of bad. If I was in the production code, I would go back and change it. I mean, it's just, when you're on an interview, it's time constrained. I mean, the only thing I would maybe change is this, but that's my excuse is that because the input is a little weird. Like if this was height, then I would just call this height. But so there are a couple of things there. But yeah, but I would say, yeah, it's an interview problem. This is very standard, which is actually surprisingly standard. And I've never asked, and well, yeah, I've never asked this problem, and I've never got asked this problem. But I feel like it comes up a lot in my colleagues asking this problem, or like, well, that's a more first-hand experience, or second-hand experience. But I've also heard other people interviewing for other companies getting this problem. So I feel like this is a very standard problem, as Johnny one man point out. So, but so whether I think it's the correct difficulty, I guess doesn't matter in that sense. So one more postmortem, I think. So I said that this code, this is O of n. Well, this code is O of n space and O of n time. But I think one thing that we made an assumption on, which that we can optimize on, is that we actually didn't need to stack because we know that there's going to be a higher height, right? So what that means is that we don't need to add this here. We can actually just put, um, like we could just do this directly up to the next peak, because we know that this is always going to be met. And that actually reduces space to of one space. And well, I mean, I think that explains why the submission was a little slow. But oh, sorry. I mean, the submission time was great, but we used a little bit more memory than necessary. So yes, I think that. So I think the code that ends up being, let me try it, is something like this. Yeah, and that would probably work. Let me run it real quick. Never know. Oh, well, I guess this is just height. Yeah, so that actually makes it all one space, and yeah, I mean, it's a clear optimization, and everything else I said, it's still true, I believe. So